video in the CSES sorting and searching video series. In this video, we will be solving the problem number 10, which is missing coin sum. So the problem statement is you have n coins with positive integer values. What is the smallest sum you cannot create using a subset of the coins? In input, the first input line has an integer n, the number of coins. The second line has n integers x1, x2, dot 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 xn, the value of each coin. In output, we have to print one integer, the smallest coin sum. Constraints are n is greater than or equals 1 but lesser than or equals 2 into 10 raised to power 5. Xi is greater than or equals 1 but lesser than or equals to 10 raised to power 9. Then we are given a sample case for which the output is 6. So first let's discuss what the problem statement is. So in this problem you are basically given an integer n, which is the number of coins you have. Then in second line you are given n different integers which are denominations of all the coins which you are having. So, or you can say value of every coin which you are having. So you have to find the smallest sum you cannot pay using any combination of these coins, or let's say any subset of these coins. So constraint is n is in range of 1 to 2 raised to power 10 or 2 multiplied by 10 raised to power 5. Basically uh, it shouldn't be our solution shouldn't be quadratic or cubic. It should be n, in worst case it should be n log n. Then our xi's are in this range from 1 to 10 raised to power 9. So let's look at sample case. So this is our sample case. Let's try to figure out why our answer is 6. So firstly, largest amount which we cannot pay, why it is 6? Because let's say largest uh, payable amount is 0. Let's take a variable largest payable amount, which is initially 0, because till now we are not saying that we are able to pay any amount. So let's take it 0 initially. Now we will check, can we pay any amount, the amount next to 0? Then amount next to 0 is 1. Can we pay it? Yes, we can pay using 1 rupee coin. Yes. Then can we pay the amount next to 1, which is 2? Yes, we can pay it using this 2 rupee coin. So we can pay amount 2 as well. Then can we pay 3? Yes, we can pay amount 3 using combination of both this 1 and 2. So we can pay 3 as well. The next amount is 4. Can we pay 4? Yes, we can pay 4 using both the 2 rupee coins. So if we use this and this 2 rupee coin, we can pay the amount of 4 as well. Can we pay 5? Yes. With these 2 coins, if we use this 1 rupee coin as well, we can pay the amount of 5 rupees. Now can we pay 6? No, there's no possible way to pay 6 rupees. Let's see why it's not possible. Because using these 3 coins, we can only pay 5. Then there is no coin lesser than or equals 6. These 2 coins are greater than 6. So if you will be using them, the amount will be greater than 6. It won't be equals to 6. So 6 is the smallest amount which you cannot pay, which is your largest payable amount plus 1. Basically you can pay till 5. So the amount you cannot pay is next to 5. Now let's take another test case which will give you even better clarity that what would be our approach for solving this one. So let's consider this test case. Now first try to figure out what are the denominations, or let's say coins we are having, and what are their possible values. So we have these coins, and let's say this is their frequency, and then let's have another variable which is largest payable amount. So let's say this is your largest payable amount. Initially your largest payable amount is 0. We can pay 0 without using any coin. Then let's see what are the coins we are having. So firstly we are having 1 rupee coin. This 1 rupee coins frequency is 2. Now, what are the amounts which we can pay? Firstly, can we pay all the amounts which are lesser than this coin? Yes. The only amount lesser than this coin is 0. We are capable of paying that because we don't need any coin for paying 0 rupees. Then, using 1 rupee coin, we can pay 1 and 2. So, the largest payable amount is 2. So, let's move to the next coin. Next coin is 2. We have two occurrences of 2. So, the frequency of 2 is 2 rupee coins is 2. So can we pay all the amounts which are lesser than or equal, which are lesser than the two? Yes, we can pay all the amounts because largest payable amount is two. That means we are not concerned about the amounts which are smaller than two. So now let's see till where we can pay because using these 2 rupee coins and previous amount, we maximum amount which we can pay is 6. So can we pay every amount till 6? Yes. How? Because we can pay two we can pay previous amounts using these 1 rupee coins, then we can pay 2 using this 2 rupee coin, then we can pay 4 using this 4 rupee coin. Any amount between 2 and 4, there's only one amount 3 that could be paid using 2 rupee coin and one of the 1 rupee coin. Then the amount 5 could be paid using these both 2 rupee coins and one of the 1 rupee coins. Then 6 could be paid using all the 4 coins. So after this, our largest payment payable amount would be 6. So we will update our largest payable amount to be 6. After this, our next coin is 3 rupees. There's only one occurrence of 3 rupee coin. So first we need to figure out, because using this 3 rupee coin we cannot pay any amount lesser than 3. So we need to figure out the largest payable amount which is should be greater than or equals to 3, because we won't be able to pay any amount lesser than 3 using this 3 rupee. So as our largest payable amount is 6, so we are not concerned about amounts lesser than 3. So let's figure out till where we can pay. Now our amounts from 0 till 6 are already sorted. So using these 3 rupee coins and these amounts from 0 to 6, can we pay till 9? Yes. 0 to 6 are sorted. Then for paying 7, we can pay using this 3 rupee coin and 4, because we already figured out that we can pay 4. Then we can pay 8 using this 3 rupee coin and 5, because we already figured out that we can pay 5 because we largest payable amount is 6. That means 5 is also payable. Then we can pay 9 using this 3 rupee coin and 6 because largest payable amount is 6. So basically, one second. Now our largest payable amount will be 9. Largest payable amount is 9. Now that next coin is 17 rupee. Now we need to figure out, because we can sort out for amounts greater than or equals 70, but can we sort out our amounts which are lesser than 17 are already sorted, because we won't be able to sort them using this one. So no, we can pay till 9 only. So would we be able to pay 10, 11, 12 using this 17 rupee coin? No, because we have already figured out that using the previous coins we cannot pay 10, 11 and all those amounts. And with 17, the minimum amount which could be payable is 17. You cannot pay amounts lesser than 17 using this coin. So our answer will be largest payable amount plus 1, which is 10. I hope everyone understood our approach. So let's move to solution. Basically what we need to do is we need to store every coin and the frequency of that coin, for which we can use map. Then as we need to work with coins in ascending order, so maps will sort out that thing for will sort out that thing as well for us, because maps already store their keys in ascending order. And then we can keep on checking that what's the largest payable amount and what's the amount which we can pay using this coin. Or else if it's not possible, then we can print our answer. So let's move to the coding part. We will take n for storing number of coins. Then we will create a map of long long comma long type m. Then we will take ll largest possible sum. Initially, largest possible sum will be 0. Then we will run a loop. Oh, sorry. First, we have to take values for our coins. So we have to run a loop m times. Oh, sorry, n times. Let's take a variable coin. Let's take value of coin. Then in increment one occurrence of this coin as we received a new occurrence of this coin. So we will increase number of occurrences for this coin. Now let's run the loop. Basically, we will iterate every key in our map. Then we will check if I dot first, that is this coin, is greater than largest possible sum plus 1. So if uh, we are not able to write the value next to largest possible sum using this coin because this coin is larger than the value next to largest possible sum, then we won't be able to use this coin to represent this amount largest possible sum plus 1. So that would be our answer. In that case, we will break our else else we will increment our largest possible sum to be largest possible sum plus the value of this coin multiplied by the frequency of this coin. At last, we will print the largest possible sum. Let's check it for the sample case. Oh, we don't have to print largest possible sum. We will print largest possible sum plus 1 because this one is possible. The next value to this is not possible. So let's try to submit it. So our solution is submitted successfully.